All right. Ariel, what'd you get for the area? What is area? Does it matter? Counting the boxes or just doing length times width, doesn't matter?
No, I was assuming that we actually like solving it for like a number.
Yeah, a number. 18, because area is how many unit squares or the boxes inside, right? So it was both counting the boxes and length times width. A few of you on your test, it said, what's the maximum area for either this garden or this farm or something? And there was like 5 of you who wrote your answer in dimensions. You said, I don't know what it was, like 10 feet by 13 feet. That's not area. Those are dimensions. If it says find the area, you should be writing the area. Okay, so don't write dimensions. So yeah, you can just count up the boxes, right? That's one way to find area. Count up the full boxes, or you can do width and length, 1, 2, 3, 4, 5, 6. And so we get the area is 18. What would we say after that? Units squared. Okay. Right. Determine now the area of our oval there. So would we go 1, 2, 3, 4, 5, 6 times 4? Is that how you find the area? What is area?
You could do that and minus the area that isn't in the circle, you know what I mean?
So, like this one approach is we can add up the squares, and then kind of like Kyle's saying, minus the missing pieces of the squares. Let's find the whole squares first. I think this is a whole square, right? 1, 2, 3, 4, 5, 6, 7, 8. Are those whole squares?
Yeah.
9 and 10. Any other whole squares in there? Yeah, maybe this one, 11, 12. Okay. Is this essentially a whole square? 13, is that pretty much a whole square? 14. Any other whole squares in there? Is this one, are these pretty close to being a whole square? 15, 16. Could I kind of take these, put them together for a whole square? So that puts me at 17, I think. Any others that can kind of group together? Maybe those two. 18. What do we think? About how many? So we could argue approximately 20 units squared, or maybe approximately 21 units squared. Yeah? But it has to be approximate, right? It's not exact. So make sure you use a squiggly equal sign. Okay, determine the area of the shaded region. Well, we have a nice little saying called RAM, stands for Rectangular Approximation Method. Rectangular approximation, because as we saw on the oval, we can really only approximate. We can't get exactly. method. On the oval, we are looking for little squares, right? So we can approximate the area underneath the curve using rectangles. Because we know how to find the area of a rectangle, right? Length times width, that's easy. Okay, so there's a few different ways to do this. We call them Riemann sums, i.e. Riemann has two ends, sums. You can either have your rectangles all have a left endpoint, a middle point, or a right endpoint on the curve. So we have an RRAM, that stands for right. So that would mean the right, top right corner would be on the curve. We have an LRAM standing for left, which would mean of our rectangle, the top left corner would be touching the curve. And then we have a center, or a mid, the middle MRAM, which would mean the midpoint of the top of the rectangle would be touching the curve. Actually, let's break these out. Grab about 3 colors. Probably want about 3 colors because we're going to be doing overlapping things here. Okay, to demonstrate the right one, I'm going to do mine in red for the right. Okay. Now, if I want to divide this into 4 rectangles, my right endpoint would have to be here. Would you say that the top right corner of that touches the curve? Yeah. Okay. I'm going to divide it into 4, and they have to be equal rectangles. They should have the same width. Sometimes that width is called delta x. Now, if I draw another one with width 1, the right endpoint has to touch the curve. So it looks like this. And you can see in this case, since if we use RRAM using the right endpoint of the rectangle, it becomes an over approximation. See how all the rectangles are higher than the actual curve? So that would be an over approximation. Okay. Now I'm going to do in green a left endpoint. Same widths. Now in this case, if I have the left endpoint, my first rectangle is actually a flat horizontal line. I can't draw a real rectangle because my left endpoint is on the origin. I don't actually start seeing the rectangle until here. So the left endpoint this time is on the curve. Does that make sense? Doing right endpoint versus left endpoint. So if I do another rectangle with a left endpoint, notice it's actually sharing the same point as the red rectangles, right? But is this one going to be an under approximation or an over approximation? Under, because all these rectangles are actually dipping below the curve. So we have a way to approximate an over approximation and an under approximation. Okay, find a third color. I'm wondering if yellow will show up. We will see. If it doesn't work, I'll pick a different color. Midpoint. Well, 0 to 1 is my width of the rectangle. Where's the midpoint? At a half. So I'm going to come up here to a half. There's my first rectangle. And then 1.5, I come up until I touch the curve at 1.5. And then square off my rectangle. And essentially, we could find the areas of each of these rectangles and get an actual number approximation, but we'll do that in a few examples. And then thirdly, I'm at, let's see, 2.5, and 3.5. Okay. All right. We're going to go do the same idea on number 1, but with a specified number of rectangles on a closed interval and find the actual approximation. Okay, determine the area trapped between the curve and the x-axis. We also call this the area underneath the curve. We have our function, square root function. It's on a closed interval 0 to 4. N equaling 2 means the number of rectangles is 2, and they have to be equal in width. So if we're going from 0 to 4, and we're going to divide this into 2 rectangles, how wide are they going to be? 2 units wide, right? So this one first is a left approximation, LRAM. So a rectangle we know is going to be width from 0 to 2, but the left endpoint needs to be on the curve. Isn't the left endpoint just right here? Okay. And then the next one is going to have a left endpoint on the curve, so that one will actually go up. So this was 0 to 2, and then our next rectangle was 2 to 4. Okay, so we can actually find that approximation now using our knowledge of rectangles. So LRAM is approximately, remember this is an approximation. So area of rectangle is length times width, right? So what's the length and width of our first rectangle from 0 to 2? You can at least tell me the width, right? Width is 2, and how tall is it? 0. So 2 times the height is however high it goes up on, like this here is 1, 2, 3, 4, 5, 6. If we went all the way up there, that would be like f of 6, f of 5, wherever the function is at f of 0. And in our case, we know that f of 0, that height, was 0. So this is our width times our height, or length times width. Plus, there's a second rectangle. Width of 2, right? Times width times the height. How high is that second rectangle? F of 2. And we can find f of 2 by plugging in here. F of 2. We have the function. If we plug in 2 into square root x, we get just square root 2. Square root 2. Okay, so our LRAM, our left approximation is approximately, since that's a 0, 2 root 2. And this is area, so let's put units squared. Okay. For things coming up, I'm also going to show you, don't they both have the exact same width? If we're talking about area, it's essentially width times the height, or length times the width. So the width is always 2 times whatever their height is, which in our case was root 0, which is just 0, plus root 2. So this was our width times the height. Because that will save us when we're doing a lot more rectangles. If you notice that they all have the same width, there's a lot less writing needed if you can pull out that width, the 2. Okay, we're going to do the same thing, but using RRAM, the right. Okay, again we need 2, so they are each going to be a width of 2. How would I draw my rectangle from 0 to 2? Using a right endpoint. Yep, so on your right side, go up until you hit the curve, which will be right here. And now you can see already it's going to be an over approximation. And then from 2 to 4, you go to your right side and go up until you hit the curve. Okay, so we have our RAM is approximately width times the height. We have a width of 2. What is the height? What's the height of this first rectangle? F of 2. Plus, we have a second rectangle, same width, but what's its height? F of 4, because we're using this endpoint and this endpoint. Okay, since we have the function root x, we know f of 2. F of 2 is root 2 plus f of 4 is root what? F of 4. Root 4. So if we simplify, we have 2 root 2 plus, what's 2 times root 4? Root 4 is just 2, so 2 times 2 is 4 units squared. You guys are doing a lot better on your test too, going vertically with your work. Vertically is better. That's our right approximation. Once we start doing more rectangles though, I'm going to show you what, if you pull out that width, this was what it would look like. Units squared. That's the width, and everything inside the bracket is the heights being added up, because they all have equal widths, so there's a common factor. Okay, any questions on number 1? Yeah. Because square root of 4, the height is not 4. The height is 2, but the width is 2, so the area of the second rectangle is 4. 2 times 2. Okay. Now, determine the area trapped between the curve and the x-axis we have a parabola instead. N equals 4. So what does n equals 4 mean? 4 rectangles on a closed interval, 0 to 4. So what's the width of each rectangle going to be? 1 unit. Yep, and so left and right, this time starting with, oh, nope, actually right. Oops, I thought that was right. Right, and then mid. Okay? So from 0 to 1, and we're using the right endpoint, go up on the right side until you touch the curve and complete your rectangle. Okay, and then make your next width. Go up on the right side until you touch the curve. Make your next width. Go up on the right side until you touch the curve. Make your next width. Go up on the right side until you touch the curve. So each of these blue points are your right endpoints. Okay, you should be saying R RAM equals, or is approximately. Use approximation symbol. I don't know why this board doesn't like me today. That's skinny. Okay. So, once you get up to more and more rectangles, it's easier to pull out this common factor like I did here and here. The common factor is the width. They all have the same width. So in this case, what's the width? 1. So that's our width times each of their heights. Now you should make sure you have 4 heights because we have 4 rectangles. So The first height, is it going to be f of 0 or f of 1? F of 1, because we're using the right endpoint. F of 1 plus f of 2 plus f of 3 plus f of 4. Is approximately I was looking at the wrong page, but yeah, they are 1. Okay, f of 1 just means we plug in 1 here. What is 1 squared? Just 1. Plus, what is 2 squared? 4. Try 4. What is 3 squared? 9. 4 squared. Okay, and if we add those up and times by 1, we have an approximation, and it should be an over approximation because all of our rectangles go too high. So let's see, 1 plus 9 is 10, plus 20, approximately 30 units squared. Are you guys struggling? Do you have any questions? Okay, then we'll do the mid, MRAM. So again, our first rectangle has the width 0 to 1, but we're using a midpoint. So what's halfway between 0 and 1? 0.5. So you come up halfway at 0.5 until you hit the curve and draw a very teeny rectangle. Then the next one is 1.5. You come up until you hit the curve and draw your rectangle. Then 2.5. Come up until you hit the curve at 2.5 and draw your rectangle. And same with 3.5. Now these are all approximations. What do you think happens when we add more and more rectangles? Say we did 100 rectangles underneath this curve, or 1,000 rectangles. What do you think is happening? It's closer. The more rectangles you add, the closer you get to the actual value. Yeah. Okay. So MRAM is approximately width times the height. Width is just 1. John, can you tell me what I should write in for the heights? Because I think that would go on the next line, right? Or like 1/4. I guess adding fractions is more difficult, so let's keep those decimals. Because did you do f of 1/2? Yep, and then 1/2 squared is 0.25 or 1/4. Okay, and then what was our next function? F of 3/2, which gives us, actually, you know what, fractions, because they all have the same, we can make them all have the same denominator, huh? So 1/4 plus 3/2, 3 squared is 9. 2 squared is 4, so 9/4. Hey, John, what's our next function? F of 5/2. If we square that, 5 squared, 25/4. And last one, John? Good. Okay, so 7 squared, 49, 2 squared, 4. So we add them up. Let's see, 10, 35 plus 50 minus 1, 84/4, which simplifies to 42/2, which is 21. Is that right? What do you guys think? $21. Notice the right we said was an over approximation because it was 30 units, and the middle we got 21 units, so it was definitely smaller. Do you think using the midpoint is an over approximation or an under approximation? Or almost even?
I think it's the closest out of the three.
I think it's the closest out of three. It really depends on the curve. But in this case, I think it's the closest out of the three. Yeah. Okay, let's try another one. That was number 2. Flip it to number 3. And like we've already mentioned, the more rectangles we get, the closer we get to the actual area. So now we're doing 8 rectangles. Okay, from 0 to 4. So Claudia, how wide should these rectangles be if we're on the interval, closed interval 0 to 4, and we're going to put in 8 rectangles? 0.5, exactly. So you just do like 4 divided by 8 tells you there'll be a half. The width will be a half. So we're doing L, the left side. So here is 1/2, but the left side is at 0, 0. So this is the tricky one. When sometimes the first rectangle is not a rectangle, it's just flat because it has a height of 0. And the next rectangle has just a teeny tiny rectangle. And because we're doing a left bound there. Now when you're doing the left, the numbers you plug in for your function f of 0, f of 1/2, f of 1, etc., you do not use f of 4. Why would we not use f of 4? When you have your LRAM, you set it up, the width was 1/2 times f of 0 plus f of 1/2 plus la-di-da-di-da. Why do we not use f of 4? You're not using it. It's the right endpoint, right? We're using the left endpoint. So the final left endpoint is actually 3.5. Okay? Now, how we done the right side, we wouldn't use 0. We would start at 1/2 and extend until 4. So make sure your beginning one and your end one are correct. Okay, will you go through and find the left approximation?
You said we're not using 4?
Yep, because we're using only left endpoints. So that's starting at 0. And the last left endpoint is 3.5. And the function is above, so you can actually find the values of all those. F of negative 1/2 is just a quadratic. In this case, I would think it'd be easiest to keep them in fraction form because squaring, you can get a common denominator. do it without a calculator. Most of the test is non-calculator. If you guys keep them as fractions, it's not too bad. You'll have common denominators. Because you're just squaring. So 0 squared is 0 plus 1/4 plus 1 plus 9/4 plus 4 plus 10/4 plus 9 plus 49/4. If you add up the integers, what did we get when we add up the integers? Yeah, 14. Add up your fractions over 4. 1 plus 9 is 10, plus 10 is 20, plus 49 is 69. 69/4. Okay, so I'd have 1/2 common denominator. I would, let's see, times me by 4. 40, 56/4. Is that right? 4 times 4 is 16, yeah. Plus 69/4. What? Oh, I times by 2 instead of squared. Okay, so we need to add 15 more, right? 79/84. Is that right? 84/4. Which actually simplifies. 84/4, is that 21? Ah, that's even nicer. 14 plus 21, 35 halves. And half of 35 is 17.5. So, arrow, because Ms. Gray likes these arrows to follow your thought, right, is approximately 17.5 units squared. Okay, let's skip for number 5. Well, okay, we're on number 4. We're only going to draw the rectangles and then skip to number 5. If we have time, we'll go back and solve it. Any questions on this one with 8 rectangles? And your little homework sheet tells you what to use for n. Does everyone still have your homework sheet? It tells you what to use for n. Oh, where is the one we needed? This one. Let's just draw the rectangles. If we have time, we'll come back and do it, but I'd like to do number 5. Okay, number 4, we have a parabola again. N equals 3 from 0 to 6. So read, how wide are the rectangles going to be? 2. And we're using right endpoint. So 0 to 2, you come up on the right side until you hit the parabola. 2 to 4, come up on the right side until you hit the parabola. From 4 to 6, come up on the right side until you hit the parabola. And 6 to 8, come up on the right side, which is actually already there, right? So that last rectangle is flat. The height is 0. Ah, closed interval, you're right. Good catch. Only to 6. Okay, what number are we not using? Since we're doing right endpoints. We're not using 0.
If it was on a closed interval, where would you go?
If it was not?
Yeah.
Well, you go until infinity. And you would die before you finished. Yeah. Okay. MRAM. Again, 0 to 6. Thanks for mentioning our closed interval. So we have the same widths, but we're using the midpoint. So what's the midpoint between 0 and 2? 1. So when you do your function, you use f of 1, and their width was 2. Plus f of the midpoint this time is 3. So you use f of 3. And then we use the midpoint 5. And make sure, did we actually get 3 rectangles on both these? Make sure your rectangles match your number, and it works. Okay? I don't think we'll have time to go through and actually solve those, but let's look at number 5. This is the last one. Application. A remote control car's velocity was recorded. Estimate the total distance driven within the given time frame. Okay. Part A, use a right approximation. Part B, use the middle approximation with n equals 10. So on A, with n equals 10, our closed interval goes from 0 to 10. How wide are each of the rectangles going to be? 1. And so you could even draw those. You might want to just go through and plot the points. 0, 1. Oh, I think these are going to have to count by 2. Yeah. And the y-axis is your velocity, feet per second. So 1, 4, 2, 6, 3, 10, 4, 5, 5, 7, 6, 5, 7, 10, 8, 9, 7, 10, 9. Okay. And we are using a right approximation. So I grab a different color. And our first one has width 1, because we want 10 rectangles. So we go to the right side and go up, which would be here. I do it lightly because you have to do it again using the middle. And the right side, and the right side, and the right side, and the right side, the right side, the right side, the right side. And since we're doing the right side, we go all the way to 10, but we're not using 0 because we're using the right approximation. You guys okay drawing right rectangles versus left rectangles?
Why do you keep saying, so you use 10y?
Because it's given to you. You want to approximate with 10 rectangles. That's given to you.
Okay, but why so we're not using 0?
We're not using 0 because 0 is a left endpoint. The first right endpoint is 1. So when we do our RRAM, the width is 1 times the heights, which start with f of 1, because we don't use f of 0, because f of 0 is a left endpoint, plus f of 2, plus, I'm going to run out of room, f of 9, plus f of 10. Okay? And then you'd go through and plug those in.
Yeah, isn't it E-looking thing the sum of the numbers?
Yeah. I wouldn't do it on this one because that will be confusing with intervals. But yeah, you're doing 1 times the summation of 1 to 10 of our function, which we don't have that's the problem. We don't have a function. If this was like the square root function, you would do x squared, where, yeah, from 1 to 10. It needs to be an I somewhere in there. It's like I equals 1. I think it's x sub I, something like that. But, okay, and then you go through and find your heights. F of 1, how tall is that rectangle? 4. Plus, how tall is the next rectangle? 6. Oh wait, isn't it just these numbers in the column? 6 plus 10 plus 5 plus 7 plus 5 plus 10 plus 8 plus 7 plus 9, and that's all times by 1. And when you multiply them, or add them all up, you get 71. Okay, so this answer would be, because it's a story problem, what are we talking about? Of what? The elephant? Yeah, the remote control car traveled approximately, remember this is an approximation, 71, is it feet squared that he travels? It's just feet. Feet from 0 to 10 seconds. So we're not talking about velocity. We're also not talking about area.
Did you say 10 seconds? Or would you say
From 0 to 10 seconds. Okay, and on part B, we'll just draw the rectangles, and that's probably all we have time for. So grab a different color. This time, it asks for an NRAM with n equals 5. Okay, so Alex, if we're going from 0 to 10, because that's our data, n equals 5, what's the width of these rectangles? 2. So from 0 to 2, that's our first width. Its midpoint, though, is 1. So our rectangle will actually look like that. Maybe I should use... Okay, and then from 2 to 4, its midpoint is 3, so the rectangle will actually look like this. And then from 4 to 6, its midpoint is 5, so the rectangle looks like that. 6 to 8, midpoint is 7. And so basically all the odd numbers. Oops.
you should fuck Alice.
Sure. Yeah, so your homework's on your homework set. And it tells you, you have to pay attention, the homework set tells you what your, where's your folders at? I think I might have stashed it in one of the folders. I think it's in folder 2. Maybe I didn't. Stash it in, did I put it in folder 3? They're done. Green, nope, just kidding. Some are pink and some are white. Maybe they're in my grading binder. Ah, here they are. Okay, well, I need these back. So don't take off with them. I added 10 points on the grade book. Ariel, excuse me. Sorry. So, again, the high was an 85. 2 people got that. Rebecca. Alex. Claudia. Hala. Anisha. Yeah, that's where partial points come in. But,